Thanks everyone for truncating your break in order to try and start this session on time. We have 3 presentations from 4 different presenters. First we're going to have Franz from SurfNet. He'll introduce himself, and he's talking about Wi-Fi deployments in campuses. And actually we will start right now with Franz, and I'll tell you about the other presenters when they get closer to speaking.
Okay.
Thank you, Franz.
Yeah, thanks, Brooke. Okay, good afternoon, everybody. What I'm talking about is alternative Wi-Fi deployments as we see it. Basically, I'm going next slide on it. My name is Frans Panken. I work for SurfNet in the wireless team. And the thing that we came across is what are the opportunities for the research and education community with respect to Wi-Fi. And in order to reveal that, 2 questions to address. First of all is what are the technical possibilities that we see in the near future? And what are the needs? And in order to see these needs, we need to explore how Wi-Fi is currently deployed. That is basically something we had some rough idea about, but we didn't need the nifty details. So if you want to see something about the future, you better start from what is there today. So in order to see what's there today, we need to explore how Wi-Fi is currently explored, how it is deployed, I mean. And in order to see that, we took 15 people we interviewed, and these were the ICT directors of the main universities and higher education in the Netherlands. And in addition to that, we have a web survey among the ICT engineers of 40 institutes within the Netherlands, and have all kinds of questions fired at them, giving insights about how many access points are deployed, how many wireless LAN controllers, where do you spend your time on, what kind of Wi-Fi capacity what are the reasons beyond Wi-Fi capacity problems, if there are at all. And in order to explore the opportunities, well, we map the technical possibilities with the current deployments and see how we go next. So with respect to the technical possibilities, this is the only slide I have about it. And these are the 2 trends I want to talk about. First of all, the trends in Wi-Fi. Well, there are various 802.11 flavors, of course, where we have the very nice things about the AC and the AD, and which gives us even more speed than we have today. Where the AC is targeting access points, whereas 802.11 AD is more for connecting all kind of deployments on the laptop and the things around the laptops to connect to the laptop. So not really targeting access points. What is also very interesting is the AH and the AF, which allows us to have alternative sizes of distances to connect clients to access points, targeting the white spaces. And apart from the real technical stuff, there is of course a very exciting 11U, where Scott will talk about, which allows us to give more flexible network discovery and also advanced authentication. Apart from the Wi-Fi and its own trend and its own deployment cycle, we have other things that are taking place. For instance, there are now controller-less solutions in the market. So not only focusing on the control architecture, but have alternative architectures in place. What is in the 3GPP is going on is from release 10 onwards, we have the automatic network discovery and selection function, which allows for an operator to have alternative ways to specify delivering access network selection and have profiles for mobile handsets. So this gives mobile operators a real advantage of having Wi-Fi deployments in combination with their 4G networks. And in combination with the controllerless solutions, there are nowadays carrier-grade controllers that allows you to connect, 8,000, 6,000 access points simultaneously. Those controllers, they're targeting for the mobile network operators, of course, like Vodafone, where they want to have a carrier-grade solution for Wi-Fi in a country. But at the same time, they can be used for the research and education community to serve an alternative way of Wi-Fi. So this is definitely an opportunity for the community to see how could Wi-Fi be offered in an alternative way. Of course, in order to support the new ways of learning that we explore, that the fact that services, they run in the cloud and data is stored in the cloud, which gives new requirements for your network access infrastructure. We have to bring your own device policy. And what we have is that students want to learn and perform research any place, anywhere, anytime, not only beyond the borders of your institution, but also beyond that. And the question is what opportunities does this bring for our community? So in order to answer that question, we did a survey about the deployments of Wi-Fi in the Netherlands, and I have some slides about that. If we look at the access points, I have to explain that at the right-hand side you have the universities, at the left-hand side you have the higher education schools, and in the middle side is the ROC, that's the vocational education, so the craft kind of educations. And I discovered this morning that basically the average of these ROCs, they should be divided by 2 actually, so sorry about that mistake. But what we see here is that the maximum is quite high. We already have 1,200 Wi-Fi access points installed at one single institute, and there's not a real difference between the universities and the higher education. When we look at the unique number of devices that we see per access point and per day, there's not a real difference between the universities and the higher education, but still 14, 12 at the average devices that connect per access point per day. When we look at the Wi-Fi controllers, these higher education already, there are some of them that have installed 12 wireless controllers in one single institute. And they're not just only used for having redundancy. These 12 controllers are active every day every hour of the day. Which basically means that these institutes, they have they started with Wi-Fi 10, 15 years ago, and they have developed onward that, from that situation developed onwards, in favor of the vendors that are offering their architecture. Which makes sense, of course, because this is the way to go forward. But they started with 1 or 2 controllers, and then they run into capacity problems. And if you run into capacity problems, you will also, of course, go to your vendor and say, "Hey, I have some problems." Well, the vendor then says, "Well, guess what? You need another set of controllers." And the next year, the same thing happens, and they said, "Well, you need another extra set of controllers." So in average, we already have that these higher education, they have an average run 6 controller in one institute. And here you see that the unique devices attached to the Wi-Fi network per controller already is quite substantial. And if you look at the unique devices overall per day, well, this is 20,000 is, of course, a maximum, but it's not something that occurs only one time a year. This hits periodically, hits this number, which is quite a lot. I have some other graphs. So if you look about what I asked them, how is your endpoint distributed over your network? So they said, well, I asked, so the numbers of these graphs, they correspond with the total number of respondents. So these are 35 different institutes that have responded. I've put it here in the slide. So 14 of these people, so there's a broad set of institutes questions, and 14 said, well, we only have 20% of the endpoints connect via wireless, and still 70% connect via the fixed infrastructure. But in the overall, more than 60% say that 60% of the institutes claim that more than 50% of their endpoints are actually connected to the network via the Wi-Fi network infrastructure. Which, for my conclusion, is that Wi-Fi is not something that you do as an alternative for your fixed infrastructure. Wi-Fi is a necessity. Wi-Fi is the new Ethernet. I also asked them where they spend their time on. There are these Wi-Fi experts, and well, about 20% says, well, mainly on network maintenance, but the majority, they spend their time on troubleshooting. And oh, I had this other slide in mind. This is actually something I put in place. So we're experimenting with an interactive part of the session, which also gives you the opportunity to vote, to give me feedback, and to vote on what you think is possible. And in order to do that, you can go to the address also put on the QR tag, and it's not the one that's in there. Let me go back to the slide. This is the one I want you to point your browser. So it's edu.nl/c. So if you want to have some interactive activity, you put there, and you can put your name there. And if you want to put another name than your real name, it's all right with me. You can also put your country, and then you hit the start button, and you are up and running. And then what you will see is the questions that I'm going to ask you, which are very, very important. So this is what you would see, is that what kind of... So first of all, let's ask the situation, what kind of a crowd do we have here? So what kind of company do you represent? And I'm going to... So already 17 people have responded. 22. 24. Oh, counting. So how do we see these results? This one? Ja, hè? Yeah. Taking questions is free. You have to pay to get the answers. Ctrl-min helpt niet. We're getting there? Now the next slide. Oh, I'm giving you. Oh, here we are. So, those who have to ask a question, what's an NREN? He's probably at the wrong conference. So we are here in the room with 45% representing NRENs, education and counting 45. Oh, making close finish. Someone is cheating, or? Well, other. Those of the government, or okay, that's nice. So we can go to the next question then, which is more representing from the presentation that I said. Is that what do you think? Because this is also a question I asked for all the ICT engineers in the Netherlands. Is what's the primary reason for Wi-Fi capacity problems? That's the question I asked them, and I wonder what you think is the real problem. Is it either that the network is poor, or the radio planning is poor, or the access points are old, or there's not sufficient access points, or people move around, unpredictable behavior of people, rooms change functionality from a cupboard to an education room. Oh. Already 40 people responded. This is nice. Thank you for cooperating with this. Okay. What you think is that it's on the radio access network, basically. It's either it's the network is poor, or the radio planning is badly realized, or the access points are not sufficient. Well, actually, it's not the case. So bear this in mind. So 50%, more than half, think that it's the access point that raised the problem. And the real answer is... So this is only gave you 3 options. No one answered it's a lack of manpower. Only 6... 10% said it's the poor network or radio planning. And then, of course, there's not enough access points. And here you have that the access points are too old. But if you look at these two, so this one and the yellow and the green, light green one, it says people change frequently. This is unpredictable behavior. On Monday, they sit in the cafeteria, and on Tuesday, it's raining, and they sit on the other side of the university, and these ICT engineers cannot cope with that. And also a lot of people answered saying the frequent change of rooms. So they say someday the room is a cupboard, and they move some walls, and it has become a college room. And of course, the housekeeping doesn't inform the ICT, so the people that give lectures in the room, they start complaining about the bad Wi-Fi coverage in that particular room, and the ICT department thinks, well, that's a cupboard, wasn't it? No, it's not. It has become a lecture room. So this is the answer that I got from the ICT engineers around the Netherlands. Previous slide, I showed you that a lot of time that they spend their time on is on troubleshooting, and also asked, okay, if you get these troubleshooting questions, what is the primary question that you get? Well, 50% says, help, get me online. And also a lot of significant part says, they have problems with Wi-Fi in room XYZ or whatever location within the institute. Okay, then we asked, do you separate infected clients from not infected clients? Well, most of them do. Do you need a Wi-Fi installer? And for your information, CAT is not a tool that is widely provisioned. It's not widely used within the Netherlands. And we also wonder whether there is a need for it. I think the answer is yes, there is a need. So more than 50% says, either says, yes, we need it, but we're already making use of it, or yes, but we do not make use of it yet. So of course we have to do something with this information. Apart from the results, it also documented in a report which can be downloaded from surfnet/mobile website. There is an Analysis Mason report that indicates the costs. What are the costs when you do some indoor Wi-Fi deployment? It's an expensive report. I actually didn't buy it. They have this is a subset of their results. I don't know why they buy their access points for 120 euros. But apart from that, they claim that the costs of the hardware is only 20% of the total costs of indoor deployments. So the majority comes from planning, pre-planning, install, commission, project management. So if you want to cut costs, probably there it's a good way to start. So I'm not sure where I am. Is it per year? No, it's starting. The starting of the deployment. No, it's the starting of deploying a Wi-Fi access network. Or the first year. Okay, in summary, well, definitely the movements about the cloud, towards the cloud. The data is towards the cloud. So there are in the Netherlands there are two kinds of institutions that you can distinguish. It's the intelligent campus, where they still do. They have a very rich campus network. They do their own. They do local services. They have data centers. And you get the other one, which is a campus network that functions as an access network for data towards servers, SurfNet. So basically what they do, they get all the data packets that they get, is they get it as fast as possible to the connection that connects them to SurfNet and the rest of the internet. This is no surprise for you. Wi-Fi is a new Ethernet. It's definitely no luxury. So more than 60% responded saying already more than 50% of our endpoints are connected via Wi-Fi. What we also see is that they initiated something, so a local setup, and now they are working towards this more serious, more commercial solution that provides them access all through the campus, all through their institutions, through their buildings. And what we also see is that it's a common solution. So everybody has a controller architecture. It's not that some institutions still have some access points that are connected directly with the internet. No, it's a common solution applied to every institute throughout the Netherlands. So this is also a good base for doing something alternatively. Movements, either from people or locations, and the access points, they are the real reasons for capacity problems. And there is actually some possibilities for sharing Wi-Fi resources and reducing costs. Because after all, we are a research and education community. And as a role of the NREN is also to think about how can we lower costs for our customers, because we are part of that community. Having in mind that these high capacity carrier grade Wi-Fi controllers are available on the market, there is a potential just for a community to offer such a controller, a centralized controller, where various institutes can put on an access point that automatically connects to the controller and you're in business. Another possibility of sharing is troubleshooting. So every institute in the Netherlands reinvents the wheel. It reinvents the Wi-Fi wheel. I'm not saying it's a bad wheel, it's a good wheel, but it's reinvented over and over again for each institution individually. And there's some potential for sharing there. Sharing on equipment and sharing on troubleshooting. So for instance, what's wrong with 0800 EduRoam? Where people can call and says, I have a problem with connecting to EduRoam. How do I solve it? If you have a central place to take care of those kind of troubleshooting problems, you reduce a lot of costs. And there is also an opportunity because these vocational education, these institutes, they just started with Wi-Fi. So of course you have the installed base, where there's a lot of investments already put in Wi-Fi. These are the institutes that just start. And the same with high schools, and the same with smaller educations. So there's a potential for them to serve more effectively. Start with them, and then perhaps the ones that have already have the basic infrastructure will follow in a couple of years. So this is also the next step that we have envisioned with that respect. Next week I have a meeting with 6 different institutes to talk about this. Talk about sharing a Wi-Fi resources, sharing a centralized controller. Put some things here in question mark, but it's also not something from SurfNet to say this is the way to go forward. I want them to answer the questions. I want them to put requirements on them such that we make the proper decisions. But some of them that could make sense is that they have access points that automatically register with them with a centralized controller, a centralized management solution where each institute can have their access to their own environment and allows them to manage their own institute. Why should all data go to the access to the controller? You can just have local breakout for data, but still have the control messages go all the way to the controller. With the situations that's going on with the 3GPP about the network selection methods, having such a central place for controlling Wi-Fi could actually be a very good step forward for any place, anywhere, anytime vision to also introduce LTE or 4G connectivities. And in addition, well, of course, this is not something that we will start with, but having a centralized controller is actually a very good opportunity to integrate this with Radius and ease the installation and deployment of EduRoam, because these institutes that have not very much ICT experience, they don't have experience with Radius, and they find it spooky. So integrating this with a centralized controller could have some real nice things about EduRoam as a service. And if you have that, of course, you can use it as a base to also realize a federation as a service. The second thing about sharing a help desk, the 1-800 EduRoam is a potential. And something that also came up is why is there not a common knowledge, a common Wi-Fi, a common wiki about sharing all kinds of configuration tips, errors, deployment. And this is something within the Netherlands, a person with the university has started this. Okay, this is the slide about the questions, but I actually want to skip that. And I want to go back to the interactive part, and I want to point you back to your device and says, okay, having in mind a centralized solution for Wi-Fi, what do you think that the barriers are for an Android to deploy such a thing? So if you go back to your laptop, or smartphone, there should be a possibility to give your opinion about that. So you think the main barrier is, oh, how many respondents do we have? Unfortunately, I do not have a next slide that gives you the answer, because this is also something new for us. But I really value your input. Yeah, I don't know. It's also my lack of inspiration of having more questions about it. You have a question?
Just an observation in the United States, we're seeing increased.
Sorry, but I can hear it.
And say your name to the people on the stream.
Shell Wagoner, Internet 2. In the United States, we're seeing an increased role of the commercial carriers in the Wi-Fi space as a way to offload off of their cellular networks. And they're using universities as a Trojan horse to do that in city areas where it's harder for them to get enough real estate to put in a lot of WAPs. So, part of what you say here, does the NREN have a role? It's interesting for us to see what's happening with the commercial carriers and the role that, there's still battles within those carriers as to how much of a role Wi-Fi has. But they seem to be hedging their bets and investing in both right now, in 4G and in Wi-Fi.
Yeah, so also operators embracing Wi-Fi is one of the possible radio access technologies. Klaas?
Klaas Hierga. I have to say I'm very skeptical about the idea of providing central controllers. I also wonder if that is really something you should want. One, I think, pretty important downside is that it's very hard to be innovative once you have such a megalomaniac central solution. You are kind of creating these big Nortel, Ericsson telephony switches in some sense, which, well, I think my employer would jump at the opportunity to create such a thing for you guys. But as a citizen, I would think this is probably not the right way to go. And I also wonder, you say Wi-Fi is the new Ethernet. Why are you as SurfNet not providing Ethernet switches for all universities and centralize that as well?
Well, well, we offer an Ethernet socket, and that's the demarcation point for offering the service. And of course, if you have Wi-Fi as a new Ethernet, you have something to push the envelope.
I mean, it was half jokingly, but I think it is important to realize that for a campus, it is important to have control over what is happening with your network, where the traffic is flowing, etc. I think it is really hard to centralize that and cater. I mean, the other thing you mentioned in passing, that I think is a brilliant idea. Provide a controller for the smaller institutes, for conferences, for stuff like that. I think that's a brilliant idea, and you should do that rather sooner than later. It's the massive deployment, the 12 controllers per institution now, and then you want to combine all those institutions so that you get 100 controller type of deployment that I'm concerned about.
Okay, perhaps one remark, Klaas, because what I forgot to say is that there is no one-size-fits-all solution. I'm not saying that the whole world should move towards a centralized control idea. I'm just saying the institute that's starting Wi-Fi, this is opportunity for them to lower the opportunity to get connected And whether the rest of the world that already have an installed base and will hook on to that, I don't know. Time will tell.
It's a short question.
Wait, no, it's actually a statement. So Philip Hansett in Rome. I want to say that we see in the US a low unemployment in IT. So trying to find wireless engineers is really a pain in the neck. So if you get this kind of shared expertise, of course, if it comes with the centralized controllers, it could be a problem. But that is definitely an advantage to provide centralized expertise from an NREN maybe, or between schools. The centralized controller, I remember the problem with EduRoam, like in London, where the schools are close to each other, you can easily address those with a centralized controller. Yep. And the last one is really easy also for KPN to acquire it later on. This is sarcastic, of course.
And some of those topics will actually be, well, this is not on now, right? It's on now. So yes, put your hands together for Franz Panken. Thank you very much.
Thank you.
The slides are available online, and you can watch the stream, which is either live now or will be archived very soon. Our next speaker, Scott Armitage from the University of Loughborough, has been doing some very interesting things on 802.11u. Successive demos of his presentation has reduced it from 45 minutes to 35 minutes, getting very close to the 30-minute mark. I won't cut into his time any further.
Can everyone hear me? Okay, so this afternoon I will be talking about improving the EduRoam experience using 802.11u. I'm Scott Armitage. I work for Loughborough University in the UK. However, I'm also a member of the EduRoam UK support team at the national level. Okay, so in my presentation today, I'll briefly introduce what is 802.11u and Hotspot 2.0 and Passpoint. And then I'll cover what benefit is this to the EduRoam community. And then finally, towards the end of my presentation, I'll show you some current 802.11u in action. So, what is 802.11u? 802.11u was an amendment to the 802.11 family of protocols. Back in 2012, however, the IEEE updated the standard, and 11u actually just got rolled into the current standard. So technically 802.11u doesn't exist anymore, and it's now 802.11 2012 into working, but everyone still refers to it by its old name of 11u. So what does this provide? Well, currently, if you want information from a network before you've joined, so if you're not associated to a wireless network, all the information you've got is the beacon. So you know pretty much the SSID. And that's the limit of the information. So what 11u provides is, it provides a way of querying the network to get back information without ever having to actually join that network or authenticate. And the way it does this is it uses a protocol called ANQP, which is the Access Network Query Protocol. And this in turn runs over another protocol called GAS, the Generic Advertisement Service. And GAS is just basically acting as the layer 2 transport for ANQP. So we've got these ANQP queries. What can we get with them? What information can we get from the network? And what it provides is it provides some standardized attributes to your client, and then your client can use those in making decisions about what it's going to do. So some of the standardized attributes are, you've got the access network type, and these are well-known values. So is it a private network? Is it a private network with guest access? Is it a public network? Is it a public network which you have to pay to use? Then there's things like internet available. Is this network connected to the internet? And then even though 11u is aimed at .1x based networks, some vendors still put captive portals behind their .1x, usually because they want you to agree to their terms and conditions. So you can indicate that there's a captive portal that you have to go through. And this is usually referred to as ASRA, additional steps required for access. They have then got things like emergency services, whether you can reach emergency services via the network, and then some information which is useful to the client. So we've got venue information, and this is split into two sections. So first of all, you've got your group, what group of venue you are. So in our instance, we're in education, so we select education from the list of types, and then you select within that your then subtype, so a university, for example. And then you've got venue name, and the venue name is a friendly name for the location where you are, so the access point's current location. And the venue name is a string that you can type in, and it's prefixed with a language code. And the particular ISO they've used is a three-letter language code. So here we have the example of ENG, English, and Loughborough University Library. And this, with venue name, you can have multiple venue names. So you could have the venue name in English and then the venue name in Dutch. And you can also put in the support information. So you could have a venue name field which contains a phone number to contact if you're having problems, or an email address to email to report any problems. And then things like there's a HESSID, which is a homogenized ESSID. So some other information that it provides is useful in terms of the client selecting the network that it's going to join. So one of the things, and this is probably the key thing in terms of network selection, is the roaming consortium ID. And this is an OUI, it has to be registered, and Terrainer have a registered OUI, which is that one there. And you put these OUIs, these roaming consortium IDs, you advertise them, and that indicates then what roaming network this is. And so if you query the network and you get back this OI from the access points, you can then, you know that this is an EduRoam network. Another piece of information is the domain name. And this is used for identifying your home service provider. So the infrastructure would advertise the service provider's domain names. So here, for example, we've got elbra.ac.uk. And then if I've configured my client with a domain, it does a match. So it says it gets the domains from the APs, the infrastructure, and then if it matches the domain that I've got set as my home service provider, I know then that this is my home network and I'm not roaming to another EduRoam site. And then we've got the problem attribute for EduRoam, which is the NAI realm. And what this is a list of all realms which can log into this network. And this is a problem for EduRoam, because EduRoam has thousands and thousands and thousands of realms, and they change on a daily basis. So providing a list of all the realms to a client is quite a challenge. And so this is something that in the EduRoam community, if we move forward with this, is probably going to need to be addressed. Yeah. And then finally, you've got vendor-specific attributes. And there's one particular vendor-specific attribute which is of interest. Again, vendor-specific attributes are OUIs, and that's 56F9A. And that's the OUI for the Wi-Fi Alliance. And if you see that in a vendor-specific attribute, it means that this is a Hotspot 2.0 network. So what is Hotspot 2.0? Hotspot 2.0 is a technical specification that was developed by the Wi-Fi Alliance, and it's an extension to 802.11u. So it's adding extra attributes to the base 11u spec, and this allows roaming providers to provide extra information which the members of the Wi-Fi Alliance feel are missing from 802.11u. Tied to that, you've got Passpoint. And Passpoint is the certification program for Hotspot 2.0. So if you buy a device and it implements Hotspot 2.0, it can get itself Passpoint certification. So that's how the clients will see this. They'll see it as a Passpoint certified device, and that means that it's implementing the Hotspot 2.0 specification. So how is this useful for EduRoam? What can we do within the EduRoam community with this? And one of the things we can do is we can identify our home network. So whilst here, for example, at TNC, we only have one service provider, which is obviously the Dutch NREN. If you go to London, if you take a trip into London and you go to Russell Square, you'll actually find that there's several universities, all with buildings right next to each other. And if you're a member of one of those universities and you're in your own building, you can actually see beacons being broadcast from surrounding universities. And this can cause a problem for you because your device doesn't know which eduroam network it belongs to which university, and it will just join any eduroam beacon that it sees. And this can lead to problems. So for example, I'm at UCL and I'm connected to the network, I've got my shared drive mapped, I can access printers, and then suddenly my device connects to the eduroam network being broadcast by SOAS. And then I lose access to my shared drive, I lose printing ability. In fact, I lose all active connections I've got open because I've jumped from one university's infrastructure to another university's infrastructure. And then even worse, you can find your device ping-ponging and bouncing between different infrastructures. So 802.11u provides us a solution with this. Because we've got this domain, which identifies your home service provider, and your device will prefer its home service provider, what it can do is it can see that the eduroam access points are advertising the UCL domain. I've got UCL domain configured in my configuration. I therefore will prefer that eduroam network over other eduroam networks. Another benefit of this is providing information to users. Because one of the problems we're finding now with eduroam is we're shifting away from the traditional problem, which was the authentication problem, where people were unable to authenticate, and we're now moving into a new phase where people can authenticate fine. However, once they're on the network, they have no understanding that eduroam is actually provided by different service providers. So you get a user who connects in Loughborough, one of Loughborough University's students, they connect in Loughborough. They can access shared drives, they can print, they can access particular protocols they use. They then travel to London and they join a network in London, and suddenly they can't access their shared drive and they can't print and they can't access the same protocols that they were on our network in Loughborough. And they don't understand that this is actually a different service provider. They just see eduroam, I'm joined to eduroam. Why can't I access these things? And so by providing information to the users, we can make them aware of what service provider they're actually using. And this can help then them understand that when they're not on their home network, they might not get the same service, and different, particularly if you're traveling between countries who have slightly different eduroam rules. Another way in which this is useful is in reporting problems. Because currently, if a user connects to a network, let's say again, you're in London, you connect to a network, if that network isn't sending an operator name to us, and they call up our service desk and say, I'm having problems on this network, and then we say, well, where are you connected? And they say, London. We have no way of knowing which university in London they're connected to. So if they can see the service provider name clearly on their device, they can say, I'm connected to this university's infrastructure, or even this particular access point if they've gone down to that level of identifying. And then there's the better load balancing between service providers, because one of the things that Hotspot 2.0 provides is connection metrics. And so, in theory, moving forward in time, by getting these connection metrics, your device can be a bit smart and say, actually, I'm not going to join this particular access point or this particular service provider's network because it's heavily loaded at the moment, and instead I'll join this other one, which is much more lightly loaded. And then finally, you've got the easier client configuration, which is one of the goals of the Hotspot 2.0 working group, is to simplify the configuration of .1x networks. At the moment, there's not much detail on how this is happening, because it seems no more or less difficult to configure an 11U network than just a standard .1x network, but that is one of the goals of the working group. So what have we been doing at Loughborough University? One of the things we've done is just done some testing with the current 802.11u equipment. And to do this, we were using the Terrainer OUI, and we just used our Cisco unified wireless access points that we have for our campus. So we just used our campus infrastructure. We actually used a couple of SSIDs, but different SSIDs. We didn't broadcast this on eduroam, but we did use the Terrainer OUI. As well as our Cisco APs, we also used host APD, and to do that, I compiled a special version of OpenWRT with 11U support, and we were running that on an MR3020, which is a small TP-Link access point that costs around €25. And if anyone has an MR3020 and is interested in doing some 11U, if you just contact me and I'll provide you with our OpenWRT image. We also ran it on a Ubiquiti UAP Pro, which is a cheap enterprise-grade access point. So we put OpenWRT on that and also did it on that. In terms of the client side, we tested using an Ubuntu laptop with WPA supplicant compiled from the latest Git release. And then consumer devices we tested with Samsung Galaxy S3 and a Galaxy S4. So if you have a Cisco infrastructure and you want to configure your 11U, after you've set up your network and you go to the 11U settings, this is what you'll see. So first of all, you just enable 11U. Then you can indicate that this is connected to the internet. And then we've got our network type. Currently, this one's just set to test or experimental. These network types, they're well-known values, so you just choose one from the drop-down list. So for EdgeRoam, it'd probably be a private network with guest access. Then we've got our network auth type, which has nothing to do with the .1x. This is to indicate, for example, if you have to go for a captive portal once you've logged in. We're not interested in the HESSID, the homogeneous ESSID. Then we've got our network address type. So here at Loughborough, we use global public addresses, but you can also indicate if you had NATed addresses, carrier grade NAT. And then we've got the IPv6 type. And this is just a straightforward V6 available, V6 not available. So moving on, we've got our OUI list, and this is our roaming consortium ID. And you can see here we've just added the Terrainer roaming consortium ID, and we've put that in the beacon, so that's in the beacon. You can put free roaming consortium IDs in the beacon. If you have any more than free roaming consortium IDs, they have to be queried for using an ANQP query. Then we've got our domain name list, and again, this is to identify the service provider to the device. So we've added our domain for Loughborough, elborough.ac.uk. So anyone then who's got a client and their domain is configured as elborough.ac.uk will treat this network as their home network. And you can add multiple domain names to this list. Then over here we've got the tricky one, the NAI realm list. And just for demonstration purposes, I've added Elborough ACUK to this list. Now, the problem we found through testing is that the Hotspot 2.0 specification says you have to return an NAI realm list. That is part of the specification. But what we found is that some clients, if you return a realm list and their realm isn't in the list, they will not connect to that network. And so if you think in the terms of EdgeRoam, where you've got thousands and thousands of realms, this is a bit of a problem. However, equally, what we've found is every client we've tested with so far is happy with an empty list. So if you just return a blank list with no realms in it, then the client's fine with that and will connect. But technically, that's not meeting the specification. And if in future someone did come up with a new client and they might decide to code this so it's strict to the specification, then that's going to cause an issue. Then we've got on here the cellular network information. And this is, again, because of what's driving 11U. 11U is being driven by commercial operators, your BT Open Zones, your Swisscoms, and also people like Telefonica, Vodafone, who are interested in offloading their 4G and 3G traffic onto coffee shop networks, onto other hotspot providers. And so you can indicate here if you have a partnership with a particular mobile operator. So this is just an example here. We've got 23411, which is one of the codes for O2 in the UK. By the way, we don't have a roaming agreement with O2. This is purely just for demonstration purposes. So moving on from that, you can then configure your Hotspot 2.0 configuration. So you tick this box and that will turn on the vendor-specific attributes. We've then got our connection metrics, which at the moment are quite dumb. They're all just set manually. These aren't sort of dynamically generated. And you can see here we've set our one link to be up. It's a symmetric link, and then we specify the bandwidth available for that link. You can then, as well as the venue information you've got in 11U, the Hotspot 2.0 also has an operator name, and so you can add an operator name field. Again, it's sent with a language code. It's a 3-digit language code because of the particular ISO they're using, and you can add multiple operator names. And then we've got here a port list, and this is for indicating which ports and protocols are available on this network. So you can indicate to clients before they even join which ports and protocols you support. And here just an example of ICMP. So the clients, in terms of testing, we tested with a Galaxy S3 and an S4, and out of the box, the passpoint menus aren't enabled on the S3, and you have to go to the phone dialer and type *#468776820#, which if you convert that to the letters is *#hotspot20#, and that will then enable the passpoint menus on an S3. From doing a bit of debug and a bit of looking at what's going on the phone, we figured out it was looking for a file in the root storage called cred.conf, and this is where your 11U settings are placed. Unfortunately, from testing, we discovered that the Galaxy S3 is broken, and whilst it's quite happy to do the ANQP queries, it'll pull down the information from the wireless network, it doesn't ever want to connect to a wireless network. It's been sort of nobbled in that way. Luckily, though, the Galaxy S4 seems to work fine, and you also don't need to do this typing of that. The Galaxy S4 out of the box, the passpoint menus are there, and it seems to work fine. And again, it's using a cred.conf. So what does cred.conf look like? Because underneath under the hood, a Samsung phone or any Android phone is running WPA supplicant. It's just a straightforward cred.conf as you would put in any WPA supplicant config. So if you want to see how these are constructed, you just look at the man page for WPA supplicant. But just showing you what's in a cred.conf. You've got your credential block here, and then we're identifying our realm, which is Elberacer UK. Because we're using TTLS, it's a username and password, so we've got user at Elberacer UK, our password. We then point to the CA we're using, and this is we've pre-installed the CA on the device, and we're just pointing to the location in the key store where it's stored. Then we've got our roaming consortium ID. And you'll notice that there's no SSID here. We don't specify which SSID we're going to connect to. We purely do the selection based on our roaming consortium ID. And then we're identifying our home domain. So this is our home service provider, elbera.ac.uk. And then, of course, what EAP type we're using, TTLS MS-Chat v2. So what does this look like in terms of the menus on the phone? So here we have an S3, and you can see we've got this use passpoint and passpoint roaming, and you just tick those to enable them. On the S4, it's a little bit different. We've just got a passpoint, and you just have a slider to turn that on. So from now on, it's all S4 because the S3 doesn't really do any connection stuff. So once you've turned on your passpoint, you can scan for a network. You don't have to scan for a network yourself manually. It will just, like any other phone, it'll just scan for networks in the background and join them as it finds them. But you can actually kick off a scan yourself. And you can see here, we've actually discovered two networks called 11U test. So these have both got the same SSID. However, they're being operated by different operators. And it's telling us that the service provider for this one is Loughborough University, and the service provider for this one is Camford University. And we can see here that it's actually connected to one of those. It doesn't actually tell us which one, but we can assume it's the one which is the best match. In the middle here, you can see if you go to your network list, what it looks like when you are connected. So here, our device is connected to this HS2 test, and you can see it says connected via passpoint. So it's indicating to us that it's connected to a passpoint network. And when you are connected to a passpoint network, you'll get this little symbol up in the top corner there indicating that you're connected to a passpoint network. Here, if you at one of these other networks also had passpoint enabled and we weren't connected, where it says secured there, it would say after it in brackets passpoint to indicate that it's a passpoint network. And then if we tapped on this to show the details for this network, you can see here that it gives the details and it'll tell us the security is .1x. The service provider for this network is Loughborough University. And then from the venue information, it's telling us the location which we're connected to, which is Holywell Park, which is the building in which I work. So it's providing useful information to the user about where they're connected and which service provider they're using. So moving on, when you're, as I say, you have home networks and roaming networks, and the device actually tells you which one you're on. So going back just a moment, it's hard to see, but that actually has got a little R on it, and that indicates that we're on a roaming network. So what you'd see is if you're on your home network, it'd come up with a H to indicate the home network, and when you're roaming, you get an R. And then you can see here from, this is just a screenshot from the drop-down tray, and it shows us here we're connected to the SSID HS2 test. It's a roaming network, and then it tells us it's at Holywell Park. It's giving us the venue information, and then there's just this nice enjoy using Loughborough University Wi-Fi network. So if you capture the output from the WPA supplicant on the phone, you can see what's going on. And you can see here it's sent out ANQP queries to all the access points it can see. And this one's responded, and it's responded with the 11U results. And then underneath, it's responded with the Hotspot 2.0 attributes as well. So once we've got those back, we decide which network we want. So here it can see two different networks. So one of them, EA74, it's decided as a roaming network because it doesn't match our domain. And it's decided that EA75 is a home network because it's matched our domain. And so the next phase, of course, is it selects one of those networks. And so here we can see we've connected to EA75 because it was our home network. And then you can see here selected pass point and then the SSID 11U test. So that's all great. It all looks good. But what are the problems? The main problem is this NAI realm and the requirement for it within the Hotspot 2.0 tech spec. At the moment, client devices don't seem to mind if this is blank. However, that's not really meeting the specs, so that could be a problem moving forward. There is this idea that you could, because ANQP could be passed off, it can be proxied, there is this idea that you could set up an ANQP server which queried and got all the Eduroam realms. So your device queries the network then queries a server and pulls down all the realms. There's a couple of problems with this. One is it's a lot of realms, and I don't know what a phone would do if you passed it, several thousand realms. The other problem is these servers don't actually exist. No one's actually implemented one. So that's another problem. And also then you've got the time. I mean, your device isn't going to wait around forever to get a realm list back. So you've got the time it takes to do that. Then other problems. Currently, there's not really much 11U technology out there. There's only Samsung S3, S4 and an LG phone that have applied for Passpoint certification as a client device. So at the moment, there's just not much out there, and the same with the APs as well. But this is changing. All the vendors are pushing this hard, and they're all developing and interested. So I'd expect over the next couple of years that most things coming out will be Passpoint certified. And then the final problem is that this standard is being driven by commercial providers. It's being driven by your BT Open Zones, your Swisscoms, your Telefonicas, and their ideas of a roaming network don't necessarily align with Eduroam's ideas of a roaming network. And currently, all the features that are going in are the features which benefit them, and not necessarily the features which benefit us. So this is an issue, and perhaps something that the community can look at moving forward. Okay, so basically, any questions? If you do want to contact me, that's my Twitter, and or you can email me. And if you have an MR3020, or you want to buy one, they're only €25 to play around with some 11U. Just send me an email, and I'll provide you with our OpenWRT image, which has got 11U compiled on it. Okay.
Thank you very much, Scott.
No questions?
Questions?
Oh.
And the hands go up.
Yeah, so I have one question about the provisioning of the consortium ID to the Galaxy S4. Your screenshots did not include you having to type in this awfully long hexadecimal number. Is that something you had to do on this cred.conf on a text editor yourself, or is there a UI for that?
Currently, there isn't a UI for that. It was done by just writing the file out. And in fact, currently there's no documentation for it. If you buy a Galaxy S4, it doesn't tell you that you can create this cred.conf. I discovered that by looking at the debug output from WPA supplicant and noticed that it was trying to open this file called cred.conf that didn't exist. So at the moment there isn't. I think the plan, it's hard to say what the commercial providers are doing, but I think the plan is they're planning on using deployment tools to create these cred.confs and then push them out over the mobile phone network or push them out in some other way to your device.
So you don't know which operator requested that to be put into the Galaxy S4, because that didn't come from Samsung. That came from one of their carrier operators.
Well, yeah, I have no idea. It's just what I discovered from using it.
Okay.
Well, I realized while you were describing this that this Russell Square problem is not really going to be solved entirely. And, well, first of all, it's not going to be solved at all for guests from outside of this area. And secondly, even for people from one of these institutions, it will probably break down somewhere near the edge where they will still be switched over. Yes, so it probably the problem will be much smaller for them, but it will still exist. Yeah.
Yeah, there's no magic bullet there. It's just something that could help. It's not going to fix the problem 100%. No.
And just a quick question. Can you break something down when you turn 11U on, like you did, and you maybe misconfigure something, and can this perhaps break down connectivity for passpoint aware clients?
Yeah, I've done some testing with this, and I've tried deliberately putting bad settings that will break things, and what I've found is that the clients still work, so it won't, obviously, if you break the settings, it won't join the network because it hasn't got the right things there, but that doesn't stop it. If you just click manually connect to this network and type in your credentials, that still works. So it doesn't really break the clients. But then again, that's just with the Samsungs I've been testing with. Other clients, it may well break them. They may not like that, you know. It's hard to say. It depends on how the vendors implemented it. With Android, they all use WPA supplicant, and so WPA supplicant has coded pretty well to just sort of, if it gets duff values, it'll just ignore them. But if someone else, some other vendor, I mean like a Windows Phone or something, they implement their own version, they're strict about what they're expecting back, then that could be an issue, yes.
Thank you, Scott. Okay. In trying to keep to time, I think that we should thank Scott quickly. Many people in the room will be hoping that next week a revision to their phone operating system will support this. But until then, we can only hope. We now have Chris Phillips and Stefan Winter. All right, you've got an and between your names now. I was going to say it was a strange Dutch marriage and a double-barreled name happening. But,
Is the clicker?
oh.
I get the clicker.
Chris is the clicker. Also, you'll be able to follow along in more depth at the BOF. That'll be a half an hour after this session concludes. But for now, Chris and Stefan will be doing a double act.
Thanks. Thanks, Brooke. Is audio okay? All right. And it is kind of warm in here, so in checking time, we'll try to keep on to it. So, Eduroam, what we've been doing and looking into the future, I think in order to really convey what some of the things we're looking at with future improvements, this is not the only one. This is just one option, and we're using the opportunity today to explore this particular one and give some insight to it. And the Birds of a Feather that's after this, we encourage you to come join us and we can talk even more deeply about it. So this is going to be a story. It's going to be about 20 minutes long, not 30. And we're going to talk about the statistics, where we're at, and some of the things, some of our things that we think about those stats. Paul Deckers tweeted a couple of minutes ago about how many people, how there's 41 countries, and the number of 140 organizations and 768 devices that have authenticated with greater than 20,000 authentications before 11 a.m. here at the conference. And I think that's a really great sign that indicates just how far Eduroam has spread. We have 10,000 plus points of presence in the Eduroam SSID. We have 60 plus countries and 27 in pilot. 60 million successful transactions across the Eduroam infrastructure. And that's not 60 million centrally done, it's distributed. So when you look at a particular hour, we have certainly an interesting spread. There's a lot more, I'm looking for the laser pointer. We have a lot of activity in certain countries that have been using Eduroam a lot more early on and have a lot more coverage than some other countries. And from the spread, in a given hour, there's about 10 to 13% is international traffic. So as you look at the backdrop of any future improvements, you have to take a look at what's happening on the infrastructure. So this is the tableau that we're thinking about. EduRoam today, and I think that this audience here, many experts created some of this. This is the background of what is in place today. And again, time, we'll just save on the time, and we're looking at predicting what growth there would be. It's hard, but at least we have to give it a swag. So we need to do this to preserve the quality of EduRoam, as well as we need runway to act, because anything that we do in such a large infrastructure is going to take time to deploy, and it's going to take time to work with all the partners in the infrastructure as well. And so these slides are on the TNC website, so you can go and take a look at them. But these numbers of the ratios and the actual traffic is derived from the monitoring.eduroam.org, and I want to say thank you to the operations team who support that infrastructure, because we wouldn't be able to have these statistics without that. So what we've done is we've taken the ratio of 2 root servers, 87 countries, and 10,000 sites, and we said, well, what would happen in 3 years' time? Well, we have a finite number of countries, about 193, and what would it look like 3 years out? If we kept on going in the same pace that we had today, our estimation is that in the current model, you have to have at least an additional root server, you'd have about 117 countries, and you'd have 13,000 sites plus easily. And I do have a number discrepancy there, but it's 117 countries with 114 domains or domain names within those countries that would come on, and about another 575,000 sign-ons per country added into the infrastructure. So when you think about that, how can we scale things? So why would we do something different? Well, we know that mobility is explosive. Just those login numbers from today, everyone's carrying either a laptop with a phone. I've seen a number of people today with 2 phones because they're either domestic and then they have an unlocked one that does international roaming, and you have the tablet. So you're at least at 2.5 today, and we know that from the previous presentation that Wi-Fi is the new Ethernet. So that's going to be the way people are going to connect. The total cost of ownership, it's not just how many ports can I put in, how many APs can I put in, but how much is it going to cost me to manage those? And that was a theme that you heard earlier on in the other presentations as well. And so there's going to be improvements, and we want to capitalize on that and any of the new technology. The other thing is that international roaming is not, the geography and the countries are not necessarily hierarchical either. So the top-level domains don't necessarily map there, and there's more top-level domains coming out. So that space is going to be spanning wider, and it's not going to have any geographic location or sovereignty there. And so who's going to be responsible for any of those domains and any of the identities within? The other thing is that the hierarchical structure, when someone goes through the infrastructure, there's a cost to this, and it's a fixed cost. And even if you said that the transaction rate was optimal for every single link, there's still a cost. So if there's a way to reduce those costs because of those transit numbers, remember that in the domestic side of thing, you have about 87% is your traffic domestically, is within your country, and that international roaming, there's about 10%. So if we're going to have more devices, we're going to see more people being more mobile. And the density that was described around here about the juxtaposition of institutions, we're sure we're going to see more activity there as well. So we have to look at ways to look at improving this and keeping things more robust. And so we need to break away from the curve of growth, the hockey stick curve of this growth and mobility. It's great, and everyone loves using it, but we don't want to bear the same costs on that hockey stick. So we need to find a way to break away from the growth curve so our costs don't scale that way too. And so now I'm going to hand it over to Sven.
Testing, 1, 2, 3, good. Thank you, Chris, for explaining the problem statement so well. And so quickly, actually. So I have more time to talk about the solution that we've been envisaging. Some people might now think, it's Stefan again, so he will try to sell us RADSec. Actually, I'm talking about RADSec, but it's not the end of the line. So there is a bit more to it. What you've seen there is the hierarchy, and this is how we set up EduRoam like 10 years ago. And we didn't think or didn't have to think much about which sub-problems need to be solved to get an end user to authenticate at his home institution. There are actually 3 sub-problems associated with this. So the one problem we have is For the username, which is at a certain realm, so let's say at restina.lu, you have to find a server and an IP address of an authentication server that authenticates you. The second problem is, once you know that IP address, you should verify that this host is actually trustworthy, so you want to send the user's authentication packets to that spot. And the last problem is that you have to then actually exchange the authentication packets and actually get the authentication done. We didn't have to think much about this because radios over UDP, as it was conceived like 20 years ago, had a very simple solution for that. It's just all in a config file. So what you have in your typical radio server is that you can specify in this text-based config file, there is a realm called restina.lu. This is the IP address to talk to. This IP address is trustworthy because I've entered it manually in the config file, so that is where I put my trust in. And to talk to that authentication server, there is a shared secret, which is based on very weak crypto these days. But yeah, this is the radio solution, and we've been doing that for 10 years now. But we discovered very early on that doing this on a worldwide scale is not going to work if you have a config file with 10,000 IP addresses and shared secrets, and something changes. This is just a mess. So what we did in the very beginning was to break this down based on the top-level domain. So we have .lu for Luxembourg, .ca for Canada, and so on. And that worked pretty fine. We already lost a couple of realms in the process, which we now have to care dearly about. And this is the .net.org, where we just can't say which country should we route this to. So this is one ugly part of our current infrastructure. So the time had come at some point, and that was like 5 years ago, to think about something that scales much better and is not based on plain old text config files. And this is where RUTSEC really came into being. So what we did back then is great. It works. It's just not taking us very far beyond the bare minimum that we need to achieve. So the first thing that you can solve dynamically without a text-based config files, the first subproblem is, how do I get from the realm name to a server name or IP address of the authentication server? The solution we had found for that is actually rather straightforward. You use DNS. Everybody uses DNS for everything. So we had this naming authority pointer record in DNS. We set up a service tag with the name x_eduroam for that. So if you have a realm, you just ask DNS, so who is responsible for this realm for the eduroam service? And you get a host name and IP address at some point. So this is something we can basically consider solved. We don't have to do anything here. DNS is proven to work, and it just does what it should. The third part of it is talking to the authentication server in a secure way. That is also something we have meanwhile solved. It was quite a bit of work. There is now RFC 6614. This specifies how to use the TLS protocol to exchange radios. So this gets us away from the shared secret. We don't have to care about this anymore. So this is also something we've solved. There is, unfortunately, this ugly spot in the middle. And I've put the done in question marks here. Because yes, we have a solution. We have made it scale to worldwide operations. This is what RUTSEC does. It is the PKI solution. So if you want to figure out, is the server trustworthy, there is a client certificate and a server certificate, and both ends can verify, do I want to talk to this server or to this client? The question, though, is this really the end of the line? And with the advent of DNSSEC and DANE, maybe it is time to ask the question, should we stay with this PKI-based solution forever? Or should we at some point think, how can we get beyond that? So now, what is wrong with PKI, really? Well, the current solution has the upside that it is using PKI, and PKI is a very well understood problem and way of dealing with things. So on a conceptual level, you can very easily say, no problem. We give the clients client certificates, we give the servers server certificates, and then they talk to us and they present their certificates, and that's it. So that is actually very nice from an architectural point of view. The problem with this approach, though, is it is using PKI. So everybody in this room probably has seen PKIs in action. Those of you who are doing grids have seen it much more in action than probably anyone would like to see it in action, because it is quite cumbersome to have a PKI infrastructure working on a global scale. So first of all, if you have a CA which issues certificates, then there are persons sitting in some office determining, should I give a certificate to this entity or not? In the eduroam case, this is basically, well, two people, me and Miro Milinovic from eduroam OT, making this determination based on the eduroam database and whatnot. However, this also needs to make sure that the person who is asking for the certificate actually is known to these people. Now, I know a lot of EduRoam people, but I don't know everybody, so you have to have some kind of identity vetting, and that actually complicates the process quite a bit. So you have to come across the person before you actually are able to issue certificates. And then even if you have solved that, well, certificates expire, certificates get revoked. You have to make sure that everybody who uses your PKI checks for the revocation status of certificates. So this is really not very nice, but, well, there is currently no better solution, I suppose. So this is what we have to work with. Finally, it gets really a lot more ugly if you go beyond just one CA, as we have right now for EduRoam, and you say, okay, if I want to scale this further on and I want to have people in Latin America to have their own CA, for example, so that they can do the identity vetting in their local context, all of a sudden you have more than one CA which is eligible for EduRoam operations, and you have to make sure that if a client presents a certificate from one CA and talks to a server with a certificate from another CA, that both of these know which are the exact CAs which are eligible, checks the revocation status of all of them, keeps the list up to date, removes CAs if they get disaccredited. So this really becomes a very hairy problem. I've always been advocating reduced TLS with PKI because, as I said, I think it's the best current thing we can do. As of late, if people have asked me, so how do we get about adding more CAs to the trust list, how to get this whole bag of things done, I'm getting more and more hesitant to say that this is a good idea at all, because verifying that all these setups actually work is very difficult. Those of you who are in the grid world will very probably realize this whole mechanism to download CAs every day, to verify the status, to update the CRLs for all these hundreds of CAs which are in place is something that can easily go wrong. And in EduRoam, this means if it goes wrong, your users are at some point and have no service. So I'm really hesitant to go beyond the one CA to rule it all. But this obviously begs the question, what can we do if we don't want to use a PKI? Or if we don't want to use more than one CA in a PKI? Now, what we've been, here are a couple of war stories, but, some of you have painfully experienced, if I wanted to give them a certificate, that I got an email which was signed by an unknown PGP person, which claimed to be XYZ. Unfortunately, I've never exchanged PGP keys, so I don't know if this is actually genuine. So this can happen. Sometimes the realm name you get a certificate for doesn't match the DNS domain name of the server that's going to handle the traffic. So me as an array operator, I don't know why that is, and if that is correct. So I have to send email to the national operator. Look, somebody requested a certificate which didn't really match. So what is actually happening there? Is that okay? And the root of all these problems, I think, is that me sitting in my Luxembourg office, I have to make decisions on something a local federation can do much more. So if an IDP in Chile, just to pick one example, has to get a certificate, the Chile national roaming operator is the person to say yes or no to that. Unfortunately, with the EduPKI CA, all of this gets centralized in my office, and I have a hard time figuring stuff out. So if we want to go further, we definitely have to decentralize this whole certificate issuance and revocation process.
So, check. Testing the sound guy, check. So if anyone recognizes this, Stefan called me out and says, what is this? That's the Zoltar future-looking guy at the Carney, normally in New York City Carney and such. When we're looking at the future, we're no longer nimble. Our turning radius is very wide now. And just like the pun of using the roam in this room is for EduRoam and turning radius of the aircraft carrier, we need a lot of runway and a lot of space to make changes. And so when we look at something and advocate a particular position, we really want to assess it in a 2 and 3 and 5 year context, because that's how long it's going to take to actually go out and have the infrastructure change. So while technology will be able to keep pace and even surpass us, it's all about how fast can we deploy and how much can we maintain. I have 3 different pieces up there, and there's a 4th one, which is the trust router and the moonshot side of things. And I've been able to have a good conversation with John Chapman, Reese, and a number of other people about where is that moonshot and trust router in those particular timeframes? And the reason that table is blank is because that's a presentation or even an entire afternoon of conversation about what it means with those pieces. So as we're looking at the technology pieces, that's, again, some of the backdrop. And the eye on the overall cost, anytime we want to explore a new path for trust, we want to say that PKI is already woven into the infrastructure. We already do some of the RADSEC pieces across, I'd say, 15 NRENs. So we know it's in there, but the question is there a better way, or can we have some improvements to that? Well, back to Stefan.
Okay, so we've been thinking about how can we do that, but always see this in the light of the previous slides. So this is a really new concept which takes years to get anywhere and needs code and actually needs RFC work in the IETF. So this is going to take a while, but it might be worthwhile actually. So as you probably know, the Dane model allows you to store certificate and public key data in the DNS. And well, that's actually it. So how can we exploit this property? Well, the thought experiment is that we can create two branches which list certificates or list public key info for all the registered IDP and SP servers that have a certificate. And we would do this under one controlled branch. So there is idp.eduroam.org and sp.eduroam.org, which, if you wanted to verify the identity of an incoming server connection, you would go there and try to find keying material and see if it matches actually what's in there, what's in the incoming request. That is something we can do. Once we have that, we have the nice property that we already have these NAPTR records for the PKI model. They can stay unchanged. So the NAPTR at some point gave you a host name to authenticate at. And if you can just say, OK, within this idp.eduroam.org, we can delegate the authority for all these things, and that's where the decentralization comes in. Let's say the Luxembourg branch gets .lu.idp@eduroam.org, and me as the Luxembourg administrator, I fill in the certificates which are needed here. And if I think this certain hostname TLD1@eduroam.lu is trustworthy as an IDP participant, I will just put under this very long DNS name the TLSA record from Dane. So if someone wants to contact TLD1@eduroam.lu and he gets a certificate in the incoming TLS connection, he can verify, OK, this actually matches. So this is the one server I want to talk to. And this is an IDP in eduroam because it has been put under this specific branch. Well, updating DNS records is a well-known problem. We've been doing this for, I don't know, 30, 40 years. So just working with DNS, once you have DNSSEC in place, is not such a big deal. So we think this decentralization works pretty well with this one. And what we have to do to get there is actually not so much. We have to put IDP and sp.eduroam.org in a DNSSEC tree. Well, that is not rocket science these days. DNSSEC is being deployed. The national branches for the countries can be delegated to a DNS server in the local operator. So that's also nothing really. It's just done. What we have to put as a burden on the national roaming operators is if they want to enable one of their participants to use the system, well, the participant has to send them their certificate data so that they can put it into the DNS. This is probably administratively a bit of a challenge, but nothing really rocket science. What we don't really solve quite yet with this one is for all those realms which are not in a specific country, like something.net or something.org, this delegation model here won't work. So at some point we will need .net.idp.eduroam.org, and we have to think how do we update this part of the DNS branch. Well, we have an eduroam operations team. I guess we could convince them to be the certificate up and downloader for these special realms, and we can have tools like eduroam.cat where people can actually send their certificates to eduroam OT with a very low maintenance effort. I think we're running over time now. Okay, so then very quickly, how would this work? So at some point, if you want to authenticate this here is the SP side. It figured out, okay, I have to talk to this realm.stina.lu. The Nepta record told me the host name is tld1 @euromlu. So what this SP does is it queries this hierarchy, whether there is a tld1 @euromlu.idp.@eurom.org, what is the key associated with that. Then it actually contacts this server and sees what certificate it gets in the actual connection. And if what it expects matches what it gets, it can connect. And that's basically it. There is one thing to keep in mind here, and it's not on the slide. In @Eurom, we always have mutual authentication. So it's not just like that the service provider wants to verify that it's contacting a genuine IDP. It's also so that the IDP wants to verify there is a genuine hotspot trying to talk to me. So all this has to be inverted for the SP part. So this server here also has to ask DNSSEC in the sp.@eurom.org branch, is there a service provider with this incoming certificate? So at this point, both parties are happy. The IDP knows that it's talking to an SP, the SP that it's talking to the right IDP, and they can just exchange their radius TLS data just as usual. This totally avoids PKI, or better put, it moves PKI to the DNS people, and we can say it's not our problem anymore, which is a very nice property. Problem is, if you take a look at what has to be done to get this working, there is something to be done. So one thing we have is the Nepta records have to be looked up by radius servers. Good thing is this is in place because we have this with the PKI model as well. It's just the same first step, so there's nothing else to do. So we are done with that one. Well, we actually need actual C code or Perl code or whatever in the radius servers so that they do consult the Dane subtree and they get the TLSA records from DNSSEC branches IDP and sp.@eurom.org. So this code just doesn't exist, so it has to be done. In the other direction, it's the same thing. So when a server gets a new connection, it has to verify that the client is actually an @Eurom SP. No code for this exists, and what's even worse is, it's not just about code. The Dane specs only foresee how a server authenticates to a client. The other way around, what we have with typical TLS client certificates, is just not part of the Dane specs. So this means we don't just need code. We have to go to the ITF and specify how does the lookup of a client certificate actually work with Dane. It's just a blank page. We have to work on that. So this is actually quite a big project. I shouldn't call it a project because nobody is actively working on it. This is just a thought and an idea, just to spark things off. But it can be made to work, and this makes it very nice. So yeah, do you want to say about things to get involved?
So this is the last slide, and we're ending just only a few moments over time. But there's a lot of places where you can get involved. There's the open spaces session. So if this particular topic interests you, put it on as a post-it note and highlight what you would like to talk about. There's again, this is one track. This is an exploration of this particular technique, and we put all our information out there already about some of the value propositions for it. There are other things that can be considered as well. The Birds of a Feather is after this at 6 o'clock. And the mobility group is just recently, the terms of reference have been recently refreshed. And that is the place, the mailing list for @Eurom, all things @Eurom. And if you don't have anyone on the governance committee, or you don't have a voice, or you feel you don't have a voice, see your regional operator and say, I want you to advocate for me on this particular thing. And if you want to get involved, just come find us. Thank you very much for your time, and welcome any questions.
Alejandro Lara from Chile would like to thank you for referencing the fact that Chile does have a successful @Eurom deployment, and his boss is actually using it at TNC at the moment.
Yay.
Questions? Microphone inbound.
So, Palacker SurfNet, I think the problem with our delegating through through DNS is similar to the problem delegating with multiple RAs. There's still this PGP signature verification thingy going on with DNS operators versus PKI RA operators. And I think the problem is similar in scope and scale. Or what do you think?
Well, this is a one-time setup problem indeed. So until we know who is operating Eduroam in a certain country, we will not delegate DNS to anybody. So we have to see that these people are these people. We have some in-band mechanisms to do that, though. So there is the Eduroam database, and getting to talk to a national operator is probably a lot easier than talking to IDP admins. And if you want to deploy Radius TLS at some point to the institution level, you need to have local people which are trusted in the place. So whether or not they become an RA for one CA, the EduPKI CA, or whether they become the DNS admin is a similar problem. Yeah. But it is still much easier to do this with DNS than with EduPKI, because otherwise we are dooming ourselves to use exactly this one CA, which is currently project funded, so who knows what happens in 2 years' time. And well, this is just a different problem. Delegating DNS is much more straightforward.
But either way, both scale to a global level and have been proven to scale to a global level. So I think we could do it. It's just the way that we do it right now. Maybe with a CA is less optimal then. Yeah,
PKI we made to scale to a global level, but only with this footnote of only with this very lightweight deployment that the national server gets one certificate, and all the national participants have to talk Radius UDP still. I don't think we can take the PKI model a lot further than that, but I hope we can take the DNS model a lot further than that. But remains to be seen, of course.
If you do have questions, conscious of time, come see us at the Birds of a Feather. Thank you very much again.
Great. And remember, you all need